Okay, so we are starting Unit 1, Lesson 5, and the key vocabulary is going to be interquartile range. We'll often refer to it as IQR. The mean absolute deviation, we'll refer to it as the MAD. We will not be calculating this. You just need to know what it actually is. And we will be referring and refreshing your memory on how to calculate mean and median. So we're going to go to a warm-up. And make this pretty big, so you do not need to really write this down. It's more of paying attention. So decide if each is true or false and explain your reasoning. So the mean can be found by adding all the numbers in the data set and dividing by the number of numbers in the data set. So if I have a dot plot, I have 1, 2, 3, 3, 4, 4, 5, 6. I have the individual data. Is the mean found by adding all those numbers up and then dividing by the number of numbers? And the answer is true, because that is how you find the mean. So mean of the data plot is 4. I'm going to give you just a little bit of time to kind of look back at this and kind of calculate, is the mean 4? So is the average of all those numbers 4? And you should be able to look at this and decide what the mean is pretty quickly, just because it is symmetric. Okay, I could fold it in half. So if I fold it in half, that halfway point is going to be at 3.5. So the question is the mean 4? And the answer is no. The mean is 3.5. So if you looked at the graph and decided what it was, or if you actually added up all the numbers and divided by the number of numbers, you're going to get 3.5. Remember, no rounding, so we don't round. And then what does the mean tell you about the data? So another thing we've talked about was mean also means average. So it's the average of where the center of the data actually is. So you need to understand that mean is a measure of center. Let's go right down here. So mean is a measure of center. On the next warm-up, same idea, you're given a graph. Now notice this graph is a little bit different. Is this symmetric? Or what type of graph is this? To me, we have a hump here, and then it kind of trickles down. So this would be considered skewed. And specifically, the tail is going to the right, so this is skewed right. So it says the median of the data set, or the data set is 9 for this set of data. So remember, median, we're looking for the number in the middle. The most common error is people would say yes because 9 is in the middle, but the numbers have to be in order. So if you put these numbers back in order, you have 1, 4, 5, 9, and 10. 5 is actually the number that is in the middle. So we just talked about this one. And remember, it's odd. So if you're looking for the median, we have 1, 2, 3, 4, 5 pieces of data. So that means the number in the middle, there's going to be one number in the middle because we have an odd number of data. So what does the median tell you about the data? And that is that half of the data is 5 or below, and half of the data is 5 or above. So if we look at our data, we have 1, 4, 5, 9, and 10. So half of our data is 5 and below. Half of our data is 5 and above. And looking at this, I don't really understand why this is here. So I'm guessing that graph does not even go with this. Okay, so moving on to actually doing some calculations. So we're going to see some new vocabulary. It says the heart rates of 8 high school students are listed in beats per minute. So when you are crunching the data, you're going to need to put your data in order. So I'm going to go ahead and do that. So I end up with 72, 75, 76, 76, 77, 78, 79, and squeeze 81 over there. Okay, I'm going to make this a little bit smaller. Okay, so we have 8 pieces of data. So if there's 8 pieces of data, that means we have 2 numbers that are in the middle. So if I were to divide this in half, I have 4 here and 4 here. So that means my 4th and my 5th numbers are what creates my median. When it's asking, or when you're being asked for the interquartile range comes from the 5-number summary. It is quartile 3 minus quartile 1. So quartile 3 minus quartile 1. So let's go ahead and complete our 5-number summary here. So if I completed the 5-number summary, I have the minimum, quartile 1, the median, quartile 3, and then the max. Again, make sure all of your numbers are in order. So the minimum, I think, is the easiest to find. Max is going to be the next easiest to find. The median, we said, is right between these two. So if this is 76 and this is 77, and I find the average of those, I'm going to end up with 76.5. Then what we're going to do is we're going to find the median of the bottom half of data, which is going to be between 75 and 76. So that's going to be 75.5. And I'm going to find for quartile 3 the median of the top half of data. So that's going to be right there. So it's going to be 78.5. So in order to find the interquartile range, like I noted here, it is quartile 3 minus quartile 1. Quartile 3 is 78.5 minus quartile 1, which is 75.5. And that is going to give me an IQR of 3. How many values are in the data set are less than quartile 1? So my quartile 1 is 75.5, which we noted up here. So I have 2 pieces of data. How many values are between quartile 1 and the median? Well, my median is right there. So again, I have 2. Between the median and quartile 3, I also have 2 pieces of data. And then anything greater than quartile 3 is going to be these. And again, we have 2. So remember, that's a whole purpose of finding your quartiles and your medians, is to divide all of the number of data into even sections, into quarters. One thing we need to talk about is, what is IQR? So IQR measures variability. Or the spread of your data. We will talk more in depth about that in a little bit. So if we move on to number 3 in your packet, it says a pod of dolphins contains 800 dolphins of various ages and lengths. The median length of dolphins in this pod is 5.5 feet, or 5.8 feet. What information does this tell you about the length of dolphins in the pod? So median is 5.8. So what that means is that half of the dolphins lengths are 5.8 feet and below. I'm going to change it to an or. 5.8 feet or below. And half of the dolphin's lengths are 5.8 feet and above. Remember, a median divides your data in half. So what this would look like is that if we have all these dolphins, and we have a 5.8 foot length here, which is my median, then that means half of my data is this and below, and then the other half of my data is larger than that. So moving on to number 4. It says the same vocabulary test with 50 questions is given to 600 students from 5th to 10th grades, and the number of correct responses is collected for each student in this group. The interquartile range is 40 correct responses. So what information does this tell you about the number of correct responses for taking the test? So when you think of IQR, so let's go back up here for a minute. So IQR. So you're looking at this. Okay? So this spot right here makes it 50% this way. This one makes it 50% that way. But remember, these divide it into quarters. So here's a quarter, 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 and a quarter. So what that means is that your IQR also represents half of your data. Okay? So in other words, what that means is that half of your data has a spread of 40. So that means that quartile 3 minus quartile 1 is going to equal 40. So I've got to figure out, how can I figure out what is quartile 3 minus quartile 1 to give me a 40? Well, there's some options here. We don't have the data in front of us, but we could have a quartile 1 of, say, 5 and a quartile 3 of, say, 45. So again, half of your data would be between 5 and 45. So that has an interquartile range of 40. Another combination might be a quartile 1 of being 10 and quartile 3 of being, say, 50. So again, you're going to have that spread of 40. So if we look at this, what would a box plot look like for the results of the vocabulary test? So what it might look like, first of all, we don't know what the minimum and maximum are, so it would depend on the min and max, but the box could go from 5 to 45 so that the IQR is 40. So remember, IQR represents spread. So IQR says, what does the IQR tell you about a data set? The IQR is a measure of variability which describes the range or spread of the middle half of the data. How do the median and quartiles divide the data? Divides it into equal quarters. So there is the same number of numbers rather in each quarter. And then how much data is between quartile 1 and quartile 3? It is the middle. %50 of the data is between these two values. And I believe in your packet we have the heartbeats part 2. We are not doing either of those. We're not learning how to calculate the MAD. So what I want you to know about the MAD is right here. Again, we're not going to calculate it. So you might want to jot this down. The mean absolute deviation, or MAD, is the average of the absolute deviations from the mean. The MAD is a measure of variability or spread of the data. This is the key piece, is that the MAD is another measure of variability or the spread of the data. So looking at the lesson synthesis, how do you calculate IQR? It is quartile 3 minus quartile 1. How do you calculate the mean? We really don't care, but what we know is, what we want to know is that the MAD is a measure of variability or spread of the data. On the next slide, it says, what are the measures of variability? So we have IQR, and we have MAD. And then what are the measures of center? We are focusing on the mean and the median. One thing that I'm going to point out is, remember what MAD stands for. It stands for mean absolute deviation. So this has the word mean in it. This has the word mean in it. So when we talk about measures of center and variability, these go together. And then IQR is found on a box plot. Median is found on a box plot. So that means these two go together.